Okay. For this video class, we will discuss priority queues. Okay. So a priority queue is a special kind of queue, and we already discussed the basic queue data structure, which is a linear data structure. So it's a first in, first out discipline. In a priority queue, it extends that data structure. However, every item in the queue now has a priority associated with it. So, meaning the element with the highest priority is the queued first before elements with lower priorities. So, if two elements have the same priority, and if your implementation allows that, they are served according to their order in the queue. So, in the order in which they are stored. So, a typical priority queue supports the following operations: insert, get highest priority, meaning return the highest priority item, and delete the highest priority item, okay, or remove it. Okay. So and there are many applications of priority queues. Here's an example where um, the character with the maximum ASCII value will have the highest priority. So let's see what happens to the priority queue as you insert values and as you remove or dequeue from the priority queue. So initially you have an empty queue, and then you insert big letter C. Okay, so what's stored is the ASCII value of character C. So you have a queue content C, then you insert O. Okay, so O has a bigger value, so it's put in front of the queue. It has higher priority. Okay, and you insert D. Okay, and now you insert D here. Okay, and when you remove the max value, what you actually remove or dequeue is the value of character 0, okay, because it has the maximum ASCII value. So you're left with C and D. Now you insert I and you insert N, okay, and you remove the max or dequeue the max value. The value of character N gets dequeued, and so on and so forth. Okay. So as mentioned, there are many applications of priority queues. Number one is CPU scheduling. For example, if you want to schedule the um, the tasks in your computer, and the CPU has to do a lot of these tasks, and each one is to be prioritized based on their, for example, priority, because, for example, some tasks are more important than other tasks. For example, uh, doing memory management is more important than, for example, rendering, for example, displaying a web browser, for example. Or, for example, in the case of real-time applications, uh, those tasks need to be ordered with a higher priority than those that are non-real-time applications. Secondly, their priority queues are also used in graph algorithms, like Dijkstra's shortest path algorithm and Prim's minimum spanning tree. The idea here is that since you want to discover shorter paths, so shorter paths will have a higher priority. Okay? So the shorter the path, the better you have in terms of your overall path. Okay? So the algorithm looks for all these shortest paths. And in general, all queue applications where priority is involved can be implemented using priority queues. So how do you implement priority queues? when you program it. Number one is using arrays. So if you have an array, you can have um, um, a structure where you have um, a an item, and each item has a key value and a priority. Okay. Okay, so you have a special data structure here, and then you have an array of these items. Okay. So you can implement then the insert operation, get highest priority operation, and delete highest priority. Okay. So when you have an array of this new data structure, okay, insert can be implemented by adding an item at the end of the array in O1 time. Okay, the get highest priority can be implemented linearly or implemented by linearly searching the highest priority item in the array. So it will take O of n. Okay, in the worst case. If you want to delete the highest priority, then you implement it by, again, first linearly searching the item and then removing the item by moving all the subsequent items one position back. So this will take, at most, in the worst case, O of n as well. So another way that you can implement this is using linked lists. So the time complexity for this, for all the operations with linked lists remain the same as the array. But the advantage here is in the delete highest priority. Since you use linked list and you're working with the pointers, you can be more efficient in the deletion process. So in short, you don't have to move items one by one place or one position back. The third one and the most efficient one is the use of heaps. So this is generally preferred for priority queue implementation because heaps provide better performance compared to both arrays and linked lists. Okay. In a binary heap implementation, such as the one we discussed in the previous video, get highest priority can be implemented in O1 time. Okay. And why? Because the value can be returned immediately by just looking at the root node. It returns the one with the highest priority. Okay. So and then insert function can be implemented in O log of n time. Okay. And the delete highest priority can also be implemented in O log of n time. Okay. Right. So and that's because it's implemented as a balanced binary tree. Okay. There's there are other types of implementations of heaps which we will not discuss, such as, for example, the Fibonacci heap. Okay, where insert and the get highest priority can be both implemented in O of 1. Okay, time complexity. Okay, so that's all for this video.